Good day, grade 8s. I'm Ms. Babo, and today's lesson we are going to be looking at the reactions of nonmetals with oxygen. In this section, we'll be looking at how nonmetals react with oxygen, what the product is, and what the influence would be on the environment. To start off, nonmetal oxides will form when a nonmetal reacts with oxygen. It is a covalent bond which forms because we are talking about two nonmetals that react or bond, and their electrons are shared. Important to remember for this section that a nonmetal oxide is known as an acidic oxide, meaning the product would be of an acidic nature. Remember, with metal oxides, it will be a basic solution or a basic oxide which is formed, and nonmetals form an acidic oxide, which means they have an acidic nature. The general formula for nonmetal oxides is a nonmetal plus an oxygen will give us a nonmetal oxide. So we are not working with metals in this section. Our first example of nonmetal oxides is between carbon and oxygen. Before we start with the equation, carbon is an organic element that can be present in all living organisms, and charcoal is actually made up of the elements of carbon. Charcoal is a black solid, but during combustion, which means the ignition of carbon, carbon dioxide can be formed. So for this reaction, we have carbon, which is our nonmetal, that reacts with oxygen to give us carbon dioxide. Our chemical equation can be represented as C plus O2 gives us CO2. Now, a positive test to see if carbon dioxide is present, we will take lime water and exhale into lime water. Remember, we inhale oxygen and exhale carbon dioxide, and that will show us that carbon dioxide is present only when the clear lime water will turn milky. As you can see in the diagram, charcoal is burning in this image and carbon dioxide is formed. Now remember we said non-metal oxides create acidic oxides, which means it has an acidic nature. So carbon dioxide is classed as a greenhouse gas which can contribute to global warming. But when CO2 is mixed with water as precipitation in the air, it forms an acid which can make soil acidic. So it can either cause acid rain or make our soil acidic if it combines with water. Our next example is the reaction of sulfur and oxygen. Before we start there, sulfur is a yellow powder, and during the combustion of sulfur, meaning the ignition of sulfur, there will be sulfur dioxide that forms. So if we have a look at our word equation, we have sulfur plus oxygen, and it will give us sulfur dioxide. Our chemical equation is S plus O2, and it gives us SO2. The positive test for sulfur dioxide is that there will be a stifling blue flame, which means a bright blue flame which will be produced, and it is poisonous. As you can see in the diagram, that bright blue flame shows that sulfur is burning in the presence of oxygen. A safety precaution that we do this experiment in is that it is performed in a fume cupboard or in the image provided in a glass beaker for safety reasons. Sulfur can also contribute to acid rain as it dissolves in the raindrops, which can produce acid rain. Remember, non-metal oxides produce an acidic oxide which is of an acidic nature. Some of the uses where we use sulfur dioxide is in preserved fruit and wine in a very, very small amount, which ensures that the fruit and the wine can be preserved. Our last example is the reaction of phosphorus. So phosphorus combusts in the presence of oxygen, and it is a spontaneous reaction, which means we do not need to ignite the phosphorus in order for the combustion to occur. It happens by itself. Our word equation is phosphorus plus oxygen, which gives us phosphorus pentoxide. Now for this example, it is not for assessment purposes. It is to show you that a reaction can take place without us igniting it, and we call it a spontaneous reaction. And phosphorus pentoxide, again, is a major culprit for pollution, specifically in water and on land or soil pollution. The last section of this chapter is to define the different types of reactions that could occur. Firstly, we have an exothermic reaction, which means energy or heat is released and the container would feel warm. An endothermic reaction is the opposite of an exothermic, which means the energy or heat is absorbed and the container will feel cold. If we go back to our two examples of carbon and sulfur, they are both exothermic reactions as heat is released due to the flame that is released and can be seen. Thank you for attending my lesson, grade 9s. We will see you next time for acids and bases.